Hi everyone, welcome to our another lecture on parametric sweep. We will change the width of the patch. So you can see that previously the patch width was 7.8 and we got the S11 result after simulation, and we found out that antenna is not operating at our desired frequency. So now again we are using the parametric sweep, and in the parametric sweep we want to reduce the frequency of the width of the page from 7.8 to let's select the value 6. So, and we are going to keep the step width size 0.5, so we will get 5 linear results. So the parametric sweep will provide us 5 reflection coefficients. Now the simulation had started. After the parametric sweep simulation is completed, we will see results for the different page width, and with respect to each page width we will get the reflection coefficient, which is S11, and we will see that whether our antenna is operating at desired frequency or not. So the simulation is complete. Let's go to the S1 parameter. This is 1D results, and let's see in the result navigator. So from here our simulation started. From here at this point, these are all the results for the 7.8. So here you can see that at 7.3 width we get this frequency, this reflection coefficient plot. At 6.8 we get this plot. At 6.3 we get this plot. At 6 we get this plot. So these were all the S11 parametric results. So from this we have got an idea that if we reduce the width of this page further, then we will reach to our desired frequency, because by decreasing the width, the operating frequency of our antenna is shifting towards the 13 gigahertz from the lower band. It is shifting to the higher band. So now we will again apply parametric sweep at this width. We will edit the value, and now we will decrease it from 6 to 4. So we have we will keep it 4.5. So we will get 4 linear results now. So now we will start the simulation, and let's see what happens, whether this frequency reflection coefficient is shifting towards the 13 gigahertz or not. So we are going to start this simulation and we will see the result. So we will get 5 S11 result. After the simulation get completed, click on OK here. Now you can see that when the simulation starts, the geometry of the page would change, the width would get reduced with each simulation get completed, and the result will be stored in the 1D result section of the S parameter. So now simulation is now complete. Let's see the result. So we will go to the S parameters here, and you can see these were the results. So click on 1D results and you can see these are the results. Go to results navigator, and we have started from 6. So let's see below 6 what has happened. So this is 5.5. When the page width is 5.5, we get this result. At 4.5 we got exactly 13 gigahertz. So the depth is exactly pointing towards 13 gigahertz. So we came to know that at 4.5 width we get the perfectly results. We get the perfect operating frequency result, which was desired in the start of the simulation. So we have finalized the width of this microstrip patch antenna, that this should be 4.5. Now after finalizing the width of the page, I am going to reduce the substrate length. I'm going to change the substrate width. So I will apply parametric sweep on the substrate width, and let's see that what happens. So I'm going to fix the substrate width to 8 and apply parametric update. Now the substrate width has reduced. So if I go to the post processing and delete all the previous results, because the previous results is now is not desired anymore, because we have already achieved the operating frequency of 13 GHz. So I will delete all the previous results. I will also delete the results from the 1D result section on the right side. I'm going to remove the parametric sweep variables. So from here we need to remove these results. So you can either delete it one by one, or you can select all of them and delete the results. So you can see that these results are not desired because they are not at our desired frequency value. So they are operating at higher frequency, and this one is at lower frequency. So I am going to delete all of them. And in the next parametric update or the parametric sweep procedure, I will select another parameter and see whether our antenna performance is getting improved with that or not. So I'm going to delete all of them, and then I will simulate my geometry. Now I have deleted all the results. Go to the 3D shape, 3D geometry, and start the simulation now. Now you see that when the simulation get complete, we will see the S11 parametric results, and we will come to know that whether the efficiency or whether the performance of our antenna has improved or not. So the simulation is now completed. So let's see the results. Go to the S11, and now you can see that this is our frequency at which our antenna will be operating. So the depth is not perfectly pointing towards 13 GHz. It is pointing towards 13.05. So if we want to shift it somewhere here at this point, which is 13 GHz, we will again apply the parametric sweep, but this time we will use the smaller step size. So we will use the new parameter. In the new parameter, we will again select the patch length. We will again select the patch width, and we will start from 4.5 to 5, and we will keep the step width of 0.2. I can select 4.4 from here. So from 4.4 to 5 with a step width size 0.2, I will get 4 linear results. So now I will start the simulation, and I will see whether the antenna performance according to the operating frequency get improved or not. So you can see that the patch width is continuously changing with each simulation. So when the simulation get complete, I will go to the S parameters results from here. I have not selected them. So now you can see that I have achieved 4 different results. I will go to the 1D results, and you can see that at 4.4, 4.5, 4.6, 4.8, and at 5 we get these results. So you can see that I can select any one of them, but the depth is lower for some patch width values, and the depth is a little not properly aligned with 13 GHz. So I can select any one of them. Suppose I am going to select 4.6 GHz. I will change the geometry in the 3D parameter from here, and I will write 4.6 here. So now the geometry of this page according to width is fixed to 4.6 GHz. I will update the parameter. So for now, as we have fixed our page width to 4.6 GHz, and we have seen previously that we got different results for the different page width. So now we have fixed it to 4.6 GHz, And in the 1D results, these were the previous parametric sweep results. Now we will go to the post processing and we will delete all the previous results. So after deleting all the previous results, now we need to simulate this geometry again so that we may get one single curve and we may properly analyze that single curve of the S11 parameter, so that we may get an idea that whether we should further optimize the geometry of our antenna or not. So now the simulation has almost completed. We will go to the result section once this process is completed. So now you can see that the simulation process has completed and the results have been obtained. So we will go to the S parametric results and we will click on S11. Now you can see that we have got only one single plot, which is for the given geometry. So here we can see that the depth is below -10 dB, which is fine, and the depth is pointing almost properly to 13 gigahertz. So up till this point we have got this geometry and we know the dimensions. These are the final parametric list, and we have got some geometry with some dimensions and its different shapes, which could make this antenna to operate at 13 gigahertz. So in this complete lecture we have learned that how we can design an antenna which could operate at our desired frequency. Using the analytical approach, we have got roughly an idea about the dimension of the patch. Then by using the parametric sweep, we have optimized the length and width of the patch and also the width and length of the substrate. So this is our complete approach for designing the antenna, and by using this approach we can operate antenna at any desired frequency. So in this whole process the parametric sweep has helped us a lot. So in the other lecture we will show you some more techniques for designing the microstrip or other shape of the antenna. So keep in touch with us and watch our next lecture. Thank you.